Welcome to the Bhutan e-learning program. I'm Khaganath Gajmer from Dampu Central School, and in today's lesson I'll be discussing about the isomerism, which is one part of the organic chemistry. In today's lesson, the isomerism is under key stage 5 for class 11 and 12. Let's look at the objectives for today's lesson under isomerism. At the end of today's lesson, we will be defining what is isomerism. We'll be able to classify isomerism and also explain structural isomerism and its type. So there are basically two types of isomerism, structural isomerism and stereoisomerism. Today we'll be only discussing about the structural isomerism. We'll also look at what is tautomerism, which is also under structural isomerism. Now let's look at what is isomerism. Now isomerism is defined as is the phenomenon of two or more compounds having the same molecular formula, but they differ in terms of physical properties such as boiling points, melting points, density, solubility, etc., and also their chemical properties like how they react with other compounds, how they behave in certain conditions, and that leads to formation of new compounds. So for example, if we look at compounds having molecular formula of C3H6O, this becomes the molecular formula of compound. Now from this molecular formula, we can have compounds of this type. So in the first case, we have one compound which is CH3CH2COH, which is an aldehyde or an organic compound, and another one with the same molecular formula, we can have a compound which is acetone, a ketonic compound. Now let's look at the classification of isomerism. Isomerism is of different types. Under broadly, the isomerism is classified as structural isomerism and stereoisomerism. Now in structural isomerism, the compounds will have the same molecular formula, but they will differ in terms of their structure. In terms of their structure, they will have a different one. Their arrangement of atoms will be different. And in stereoisomerism, they will have same molecular formula, but their position, the atom's position in the space, in the three-dimensional space, will be different. Some atoms may be lying in this position in the space, the other could be directed towards this position. So this is called stereoisomerism. Stereoisomerism means it's basically to do with the position of different atoms in different position, in the space. Now under structural isomerism, we have different types. First one, we have chain isomerism. Second one, we have position isomerism. Third one, we have functional isomerism. Fourth one, we have metamerism, and the fifth one is tautomerism. So in today's lesson, we'll be particularly focusing under structural isomerism, and then we'll also be discussing about different types of structural isomerism. Now under stereoisomerism, we have geometrical isomerism, and then we have optical isomerism. So stereo is basically to do with the arrangement of atoms in the space, whereas structural isomerism is to do with the arrangement of the atoms in the different, in the structure itself. Now in today's lesson, we'll be focusing on structural isomerism. The first structural isomerism is chain isomerism. Now what is chain isomerism? Now in chain isomerism, the compounds will have same molecular formula, but different arrangement of carbon atoms in the main chain. Now in the chain isomerism, we'll have a carbon chain, and along the carbon chain, the arrangement of the atoms will be different at different position along the carbon chain. For example, if we look at the molecular formula of C5 and H12, we'll have the following isomers for this particular molecular formula. Here, if you look at, we have 5 carbon atoms, 1, 2, 3, 4, 5. 5 carbon atoms, and this is the carbon atoms are arranged in a straight chain, and the compound name, this becomes the N-pentane, which is also known as normal pentane. Now, from the same molecular formula having 5 carbon and 12 hydrogen, we can have another compound which is 2-methyl-butane. Here, what is happening is along the chain, we have the branching in the second carbon. This becomes the first carbon, this becomes the second carbon, third and fourth. So, we have a branching at carbon number 2. So, that's why it becomes, the name of the compound becomes 2-methyl-butane. Now, we can also have another isomer for this particular molecular formula having 5 carbon and 12 hydrogen. So, it is now we can have a further branching at carbon number 2. So, we can bring this one here and then make this structure. So, here we have a further branching, and then this is called now the carbon number, this is carbon number 2, this is carbon number 1, 2 and 3. So, we have a branching, 2 branching at carbon number 2, here 1 and the one here, we have a methyl group here. So, it becomes 2,2-dimethyl, 2,2 means one dimethyl group is at carbon number 2, another one we have at carbon number 2. So, we have 2,2-dimethyl propane, propane because there are in a straight chain, in a parent chain, we have 3 carbon atoms. So, it becomes 2,2-dimethyl propane. So, this is called chain isomerism. So, all of these compounds are called chain isomers. They basically differ in terms of the chain. So, this is a straight chain, this too becomes branched chain. So, these are chain isomerism. Next, we have another type of structural isomerism, which is position isomerism. In position isomerism, the compounds will have the same molecular formula, but they differ in the position of double bond, triple bond, or even functional group. So, this is called position isomerism. The position of the double bond, position of the triple bond, or even the functional group along the carbon chain, they differ the position. For example, the molecular formula, let's have with carbon 4 and 8 hydrogen. There are certain compounds which has 4 carbon and 8 hydrogen. Let's look at the isomers. The first possible isomers that we can have is this compound. Here, if you look at the double bond, this compound is having a double bond here. So, at carbon number 2, this becomes carbon number 1, carbon number 2, carbon number 3, carbon number 4. So, we have a double bond at carbon number 1. So, this becomes 1-butene. Butene, there are 4 carbons. In, there is a double bond at carbon number 1. Therefore, it becomes 1-butene. Next compound that we can have from this molecular formula C4H8 is 2-butene. Now, the 2 compounds here, they differ in the position of double bond here. In this case, we have double bond at carbon number 1. Now, in this case, the double bond is at carbon number 2. So, therefore, it becomes 2-butene. So, these 2 compounds are called position isomers. They differ in the position of double bond here. Well, if you have another molecular formula with 3 carbons, 7 hydrogen and 1 chlorine atom, from this common molecular formula, we can have the following position isomers. For example, the first one we can have is 2-chloropropane, 2-chloropropane. So, we have carbon number 3 carbons, 1, 2, 3, 3 carbons, and then we have 1 chlorine and then 7 hydrogen. Now, the position of the chlorine here can be at carbon number 2. So, this becomes 2-chloropropane, propane. There are 3 carbon atoms. So, next one we can have from this common molecular formula is 1-chloropropane. Now, we can have a position of chlorine atom at carbon number 1. If we have another molecular formula C3H8O, we can have the following isomers. Now, in this case, we have CH2, this one, this compound, which is the straight chain compound, and is known as propan-1-ol. Ol, it indicates alcohol compound, Now, here the carbon, the OH group, the functional group OH of alcohol is there at carbon number 1. So, it is at carbon number 1. Now, we can have this same OH in another position along the carbon chain. So, the second compound that we can have is this one. Here we have propan-2-ol. Propane, there are 3 carbon atoms in the compound, and then 2-ol, the OH group is at carbon number 2. Therefore, it becomes propan-2-ol. So, we have different position in these 2 compounds. They differ in terms of position of OH group. Here it is at carbon number 2. In this case, it is at carbon number 1. So, these 2 compounds are called position isomers. In terms of, they differ in terms of position of functional group. Now, let us look at what is functional isomerism. Functional isomerism is the phenomenon in which the compounds will have same molecular formula, but differ in terms of functional group. The compounds will have the same molecular formula, but they will have a different functional group in them. For example, if we look at the compounds with molecular formula C2H6O having 2 carbon atoms, 6 hydrogen atoms and 1 oxygen atom, we can have the following isomers, functional isomers. In the first one, we can draw from this molecular formula, we can draw a compound which is CH3CH2OH, which is an alcohol. It is known as ethanol or ethyl alcohol. This is the IUPAC's name and this is the common name. Now, from the same molecular formula, we can also have another group of compound with a different functional group, which is the ether. In this case, we can again have the same number of oxygen, same number of hydrogen, same number of carbon atoms. So, this compound is CH3OCH3. Now, in this case, the functional group is ether. This molecule is an ether group. It is an ether compound. It is an organic compound. That is an alcohol compound, ethanol, and this becomes a methoxymethane. Now, these 2 are entirely different organic compounds. So, from the same molecular formula, we have 2 compounds differing in terms of functional group. For example, another one, let us have the common molecular formula that is C4H8O having 4 carbon atoms, 8 hydrogen atoms and then 1 oxygen atom. Now, from this molecular formula, we can have a chemical compound of this type with this structure, the straight chain structure, CH3, CH2, CH2, CHO. CHO is the functional group for aldehydes. All aldehydes compounds will have the functional group which is CHO. Now, from this common molecular formula, we can have this compound which is an aldehyde, which is butanol. Now, from the same molecular formula, we can also have another class of compound which is a ketone. A ketone, we can draw the structure CH3, CH2, C double bond O and then CH3. This becomes the functional group for ketone and this becomes the functional group for aldehyde. So, from the same molecular formula C4H8O, we can have 2 class of compounds which are entirely different. One is an aldehyde, other one is an ketone. So, it is butane-2-one. One means it signifies ketone, or in common name we can call it as a methyl-ethyl ketone. Methyl-ethyl ketone. Now, next one, let us look at what is metamerism, another structural type of structural isomerism, which is metamerism. It is the phenomenon in which compounds will have the same molecular formula, but they will also have the same molecular formula, they will also have the same functional group, but they will differ in terms of alkyl group attached to both sides of the functional group. For example, let us look at the molecular formula C4H10O. We will have the following isomers from this common molecular formula. Here, let us look at this compound. In this case, this is the functional group, which is an ether. This is an ether. This oxygen here indicates the compound is an ether. Now, if you look at here on this side, we have ethyl group here. On this side, we also have ethyl group. So, it becomes ethoxyethane, or it is diethyl ether. Now, from the same molecular formula C4H10O, we can have another compound. Let us look at here. These two compounds are they fall under the same class, which is an ether. But if you look at here, what is happening is what we can see is here at this side we have CH3 group. On this side we have the propyl group CH2, CH2, CH3, the propyl group. So, this compound, if you look at here, these compounds, they differ in terms of the alkyl group attached on both sides of the functional group. Now, this becomes methyl propyl ether, methyl propyl ether. So, actually they are the same group of compounds, but they differ in terms of structure and in terms of certain properties. Now, I would like you to draw another structure, possible structure, the third structure that we can draw it from the same molecular formula. You try it on your own and then see if you can. Next type of structural isomerism is tautomerism. Tautomerism, in this, it is a special type of isomerism in which a single compound, a particular compound, can exist in two readily interconvertible forms which differ markedly in the relative position of atom, usually hydrogen. Now, in this kind of isomerism, structural isomerism, you will have the compound, will have the pair of compounds, but and then they will be differing in terms of position of certain atoms, usually hydrogen. Now, let us look at this one, for example, ketol, enol, tautomerism. This compound is in a keto form. Now, if you look at this one, we have a functional group CO, which is the functional group for ketone, and then here we have hydrogen on this side. This hydrogen has that property of shifting from this position to this position, and also from this position to this position. What is happening is actually, so when the hydrogen shifts from this position to this position, this is what we get. So, we have OH here now, OH here, and then this hydrogen can again come back to this position. So, these two compounds are interconvertible. It gets converted into two forms. And in this case, why it is called ketoform is because we have a ketone here, ketonic group, CO group, which is a ketone group. Now, if this hydrogen migrates to this position and becomes OH group, and here we have OH group, this OH group is for alcohol, therefore, it becomes OL. OL, it represents alcoholic group. Now, what is En? En, because we have a double bond here, En. This compound is in a enolic form. Now, these two are interconvertible. So, such phenomenon is known as tautomerism. Now, let us look at what we have done today. Let us recap, try to recapitulate whatever we did in today's lesson. First of all, we try to define what is isomerism. Second one, we try to classify isomerism, different types of isomerism. We have structural isomerism and then stereoisomerism. And then we discussed about structural isomerism, under which we have chain isomerism, we have position isomerism, we have tautomerism, metamerism, and functional isomerism. So, these are the different types of structural isomerism which we discussed in today's lesson. So, I would like you to now work on the following questions. I would try it at your own and then see how much you have understood from today's lesson. The first question is, draw the isomers of each of the following and name the type of isomer. Once you have understood the concept of isomerism, structural isomerism, now you try this question. You draw all the isomers for C4H10, all possible isomers you try to draw, and then name the isomers, and also try to name the type of isomerism. Under structural isomerism, we have C4H10, you try to note that, and we also try on another molecular formula which is C3H6O2. You try on those two molecular formula and draw all the possible isomers that you can, and also once you draw the structure, try to name those isomers. Second question, you try to draw the metamers for C4H11N. The general formula, the common formula we have is C4H11N, and then try to draw all the metamers from this formula. And also name and the tautomeric form of HCN. You take HCN and then write the structures, the tautomers, okay, and then name the tautomeric form. So, with this, I would like to thank you for listening to my session, and then I will see you in the next session with the remaining topics, which is optical isomerism. I will be continuing with optical isomerism. Thank you.